huge amount of information. If these dots were cars going around a racing circuit, you would have absolutely no idea what's going on. So why is it we move the particular ways we do? Well, let's think about what really happens. Maybe we don't all quite move the same way. Maybe there's variation in the population, and maybe those who move better than others have got more chance of getting your children into the next generation. So on evolutionary scales, movements get better. And perhaps through life, movements get better through learning. So what is it about a movement which is good or bad? Imagine I want to intercept this ball. Here are two possible paths to that ball. Well, if I choose the left-hand path, I can work out the forces required in one of my muscles as a function of time. But there's noise added to this. So what I actually get, based on this lovely, smooth, desired force, is a very noisy version. So if I play the same command through many times, I will get a different noisy version each time, because noise changes each time. So what I can show you here is how the variability of the movement will evolve if I choose that way. If I choose a different way of moving, on the right, for example, then I'll have a different command, different noise playing through a nonlinear system, very complicated. All we can be sure of is the variability will be different. If I move in this particular way, I end up with a smaller variability across many movements. So if I had to choose between those two, I would choose the right one because it's less variable. And the fundamental idea is you want to plan your movements so as to minimize the negative consequence of the noise. And one intuition to get is that actually the amount of noise or variability that I show here gets bigger as the force gets bigger. So you want to avoid big forces as one principle. So we've shown that using this, we can explain a huge amount of data, that exactly people are going about their lives planning movements so as to minimize negative consequences of noise. So I hope I've convinced you the brain is there and evolved to control movement. And it's an intellectual challenge to understand how we do that. But it also is relevant for disease and rehabilitation. There are many diseases which affect movement. And hopefully, if we understand how we control movement, we can apply that to robotic technology. And finally, I want to remind you, when you see animals do what look like very simple tasks, the actual complexity of what's going on inside their brain is really quite dramatic. Thank you very much.
Quick question for you, though.
Yep.
So you're a movement
Chauvinist.
Does that mean that you think that the other things that we think our brains are about, the dreaming, the yearning, the falling in love, and all these things, are a kind of a sideshow, an accident? They're
not accident. I think they're all important to drive the right movement behavior to get reproduction in the end. So I think people who study sensation or memory without realizing why you're laying down memories of childhood, the fact we forget most of our childhood, for example, is probably fine because it doesn't affect our movements later in life. You only need to store things which are really going to affect movement.
So you think that people thinking about the brain and consciousness generally could get real insight by saying, where does movement play in this game?
So people have found out, for example, that the studying vision in the absence of realizing why you have vision is a mistake. You have to study vision with the realization of how the movement system is going to use vision. And it uses it very differently once you think of it that way.
Well, that was quite fascinating. Thank you very much indeed.